This wall your grandpa built absorbs heat all day and releases it all night. The $240 billion HVAC industry erased it. In the late 1970s, builders in Santa Fe, New Mexico started putting up houses that needed no furnace at all. No heat pump, no baseboard electric, nothing. The south wall of the house was built out of concrete block, painted flat black with a sheet of glass mounted 4 inches in front of it. That was the entire heating system. The sun hits the glass. The glass traps the heat. The black wall absorbs it all day long, and at night, when the temperature drops 40 degrees in the desert, that wall radiates stored heat into the house, slowly, evenly, for about 8 to 10 hours straight. By the time the sun comes up the next morning, the wall is cool and ready to start absorbing again. They called it a solar wall. The technical name is a Trombe wall, named after a French engineer named Félix Trombe, who popularized the design in the 1960s. But here's the thing. Félix Trombe did not invent it. Not even close. People have been building thick stone and adobe walls on the south side of their homes for thousands of years. The Pueblo people in New Mexico were doing this long before anyone in Europe wrote a paper about it. Your great-grandparents, if they'd built with stone or brick, were doing a version of this whether they knew the science or not. The science is simple. Heat moves through masonry at about 1 inch per hour. If you build an 8-inch thick concrete wall and the sun heats the outside surface at noon, that heat reaches the inside surface around 8 at night. That is not a guess, that is a measured, documented thermal conductivity. The National Renewable Energy Laboratory confirmed it. A 10-inch wall gives you a 10-hour delay. 12 inches gives you 12 hours. You are literally programming when your house gets warm based on how thick you pour the concrete. And the efficiency numbers are not even close to what you would expect. A standard photovoltaic solar panel converts about 15 to 20% of the sun's energy into usable electricity. A Trombe wall converts 70 to 80% of the sun's radiation directly into heat. No inverter, no battery bank, no wiring, no maintenance. Just a dark wall and a sheet of glass. The house in Odillo, France, where Félix Trombe and architect Jacques Michel built the first proper demonstration home in 1967, gets 70% of its yearly heating from that one wall. That was measured over multiple winters. 70%. And the system has no moving parts. There's nothing to break, nothing to replace every 15 years, nothing to service annually. The wall just sits there and does its job. And this is not just some old experiment that never went anywhere. The National Renewable Energy Laboratory built Trombe walls into the visitor center at Zion National Park in Utah. The wall covers nearly half of the entire south-facing side of that building, about 740 square feet of grout-filled concrete block behind a single pane of high transmittance glass. The studies showed that 20% of the building's annual heating came from that wall alone, and on winter afternoons and evenings, the Trombe wall handled the heating load entirely by itself. No backup system needed during those hours. This is a federal building designed by government engineers, using a technology that most contractors today have never even heard of. Now here's where the story gets ugly. In the 1970s, after the oil crisis, passive solar design had a real moment. The Department of Energy funded research. Universities ran studies. Builders in the American Southwest were putting Trombe walls on new construction. Solar Age magazine was publishing design manuals. People were excited because the math actually worked. Then oil prices dropped, and the HVAC industry, which today generates over $240 billion a year globally, had a problem. If homeowners figured out that a concrete wall and a piece of glass could replace a $5,000 furnace, that was a direct threat to the entire business model. Furnace manufacturers, ductwork installers, refrigerant suppliers, thermostat companies, annual service contracts. All of it depends on you believing that mechanical heating and cooling is the only option. So the building codes quietly shifted. Insulation requirements went up, which sounds good until you realize that a Trombe wall works precisely because it is not insulated on the exterior face. The whole point is that heat conducts through the mass. If you insulate it, you kill the system. Modern energy codes essentially made it illegal to build an uninsulated exterior wall, even if that wall is a passive solar collector that outperforms every furnace on the market. Builders stopped learning about it. Architecture. Schools dropped passive solar from the curriculum. By the 1990s, you could get a degree in building science without ever hearing the words thermal mass wall. And now, here we are. The average American household spends well over $1,000 a year just on heating alone, and that does not even count air conditioning in the summer. The HVAC industry is growing at almost 7% annually. Heat pumps cost $8,000 to $12,000 installed. And a technique that works with concrete, black paint, and glass, materials your grandfather could get at any building supply for a few $100s, has been effectively erased from public knowledge. Quick thing before I continue. The data on this channel shows that over 80% of you watching right now are not subscribed. That means you are showing up for the content, but the algorithm has no reason to show you the next video. If you have made it this far, you clearly care about the way things used to be, built. Hit subscribe so you do not miss the next one. The design is not complicated. You want a south-facing wall. In the northern hemisphere, that is the wall that gets the most direct winter sun. You build it out of concrete, brick, stone, or even a water-filled drums, 8 to 12 inches thick for most climates. You paint the outer surface flat black. Then you mount a single or double pane of glass about 2 to 4 inches in front of it, creating a trapped airspace. The sun heats the air in that gap. The glass prevents the heat from escaping back out. The wall absorbs it. For summer, you add a roof overhang. The sun is high in the sky during summer months, so the overhang blocks direct sunlight from hitting the wall. In winter, the sun is low and slides right under the overhang. The same wall that heats your house from October through March sits in shade from May through September. No thermostat required, no seasonal adjustment. The geometry of the earth handles it. You can also add vents at the top and bottom of the wall. Open them in summer, and the heated air in the gap rises and exits through the top vent while cooler air is pulled in from the bottom. The wall becomes a ventilation chimney. Close the vents in winter and you are back to full heating mode. The whole system is 2 small holes with a flap on them. There's a certified passive house in Ann Arbor, Michigan that has 3 trom walls on the south side. Michigan, not the desert, not the Southwest, a state that gets brutal winters with heavy cloud cover. The builder on that project, Mike Mahon, put it simply: a trom wall is a non-mechanical form of free heat. As long as there is sunshine, it will not fail. It can never break down. It is basically a thermal battery. That is how well it works, even in a cold, cloudy climate. An energy consultant named Alex Wilson, who was working in Santa Fe at the time for the New Mexico Solar Energy Association, wrote the thermal storage wall design manual back in 1979. He led workshops in New Mexico teaching people how to retrofit their existing south-facing walls with glass and dark paint. The materials were cheap then. They are even cheaper now, relative to what a furnace costs. But you will not find that manual at your local library. You will not see trom walls in any mainstream home improvement show. And your contractor has almost certainly never heard of one. If this is the kind of thing that makes you wonder what else they stopped teaching, you are in the right place. Drop a comment and tell me if you have ever seen one of these walls in person. I want to hear about it. Now, next time I'm going to show you something about your crawl space that every builder in America knew before 1955. A ventilation system that costs absolutely nothing to operate and cools your house using the ground temperature underneath it. The HVAC industry spent decades convincing you that crawl spaces are problems to be sealed up. They are not. They are free air conditioning. That story is coming. Stay close.